Hello everyone, I Dr. Sanjay Upreti welcome you to the channel Electrical Science by Dr. Sanjay Upreti. Uh, in this channel we discuss the topics related to the basic electrical engineering, and in today's video I am going to discuss a problem of a superposition theorem. So as you can see in this circuit we have a three number of the sources and three number of the resistance, and it was asked to find the current I1 in the 2 ohm resistances. So we will be using the superposition theorem as mentioned in this question. So let us see what is the statement of the superposition theorem. The statement says that the superposition theorem states that the total current or the voltage source across any component of a network with multiple independent sources is equal to the sum of the currents or voltage produced by one source acting individually. Right. So in this circuit, so there are the three sources. So we will consider one source at a time and find the current I1 due to the one source, and then we will add it up we will add all the three currents um, uh, mm, find through the three sources, and so that the total current will be current I1 can be find by using the superposition theorem. So let us take first 12 volt. Let us make 12 volt source effective. Let us take first 12 volt source as a acting source, and rest of two sources as a inactive source or ineffective source. So to make them ineffective, 6 ampere source will be open circuited, so that the current from across the terminal of this 6 ampere source becomes 0. Similarly, this voltage source will be short circuited, so that the voltage across these terminals becomes 0. So resulting circuit will be looking like this one. So in this you can see the 12 volt source is connected to the 2 ohm resistance and the 6 ohm resistance. These two resistances are connected in series, and 3 ohm resistance is not connected anywhere. It is a floating resistance, so it will not be considered, it will not take part in any current in a circuit. So let me say this current is I1 single dash due to the first source. So I1 dash can be given by, that is the voltage, total voltage here is a 12, and the total resistance is the 2 plus 6, both are connected in a series. So it will be equal to the 12 divided by 8, and it is equal to the 1.5. So I1 single dash means due to the 12 volt source, it is equal to 1.5 ampere. So let me note it down here. So I1 single dash is equal to 1.5 ampere. Now second source is 6 ampere source. So we will consider 6 ampere source acting alone. So then circuit would look like this one. So in this circuit you can see the current 6 ampere is divided into the two parts. One part is flowing into the 6 ohm resistor, and the another part is flowing into the 2 ohm resistors. So here you can apply the current division rule to find the current in the 2 ohm resistance. So current in the 2 ohm resistance, let me say this is a I1 double dash because of the second source. So I1 double dash can be given from by the current division rule. It can be given by the 6 divided by 2 plus 6 ohm resistance. This, that is opposite to the 2 ohm resistance. We are finding the current in 2 ohm resistance. The resistance opposite to this one is the 6 ohm, and divided by the total resistance and multiplied by the total current. Total current here is the 6 ampere. So it will be equal to the 36 divided by 8, and that is 4.5 ampere. 4.5 ampere. So I1 double dash, value of the I1 double dash or the current due to the 6 ampere current source is 4.5 ampere in the 2 ohm resistance. So let me note it down here again. So it is I2 double dash is equal to 4.5 ampere. Now I will consider the third source, that is 8 volt source. So circuit when 8 volt source is acting alone, it will be will look like this one. So here again the resistances are connected in a series, 3 ohm resistance will not come into the picture because it is not connected to anywhere, or it is a floating one. So current I1 triple dash, that is a third source. So let me say it is a I1 triple dash is equal to 8 divided by 2 plus 6, and it is equal to 8 divided by 8 is equal to 1 ampere. So current flowing, but here one thing is to note that the current here is flowing in this direction due to this 8-volt source. So current is opposite to the assumed current direction. So I1 dash, I1 triple dash, we will take it as a minus 1.0 ampere. So let me note down here. So I1 triple dash is equal to minus 1.0 ampere. So total current I1 will be equal to the summation of all these currents. So summation 1.5 and 4.5 is equal to 6 ampere, and when you deduct 1 ampere from here, so it will I1 will become 5 ampere. So this value of this current I1 is the 5 ampere due to the all three sources, and it can be found very easily by the application of the superposition theorem. So I hope this video will be helpful to you to solve the similar type of the problems, and if you like this video, hit the like button and subscribe to the channel. Thank you for watching.